Welcome everybody to the second session of CrossTalk and the new year in 2022. And I hope it started off well for everybody else. And I wish to welcome you all to this second session of the CrossTalk organized by MetSoc, and it's heavy conversations about light metals as the logo goes. So I'm Suman Shankar. I'm a professor in McMaster University in the Department of Mechanical Engineering, and I'm also presently sitting in the chair of the Light Metals Committee. And I would like to start the proceedings today by presenting some thoughts on land acknowledgement, on understanding that and recognizing that all of Canada resides on traditional, unceded, and/or treaty lands of the First Nation, Inuits, and Métis people. Here, I would like you to bring your attention to a map which shows all the treaties that we have now put together, and the lands is where we learn, we work together, and we also hold very close ancestral connections and stories of the Indigenous people since time immemorial. Land acknowledgement can be an act of reconciliation towards the rebuilding of relationships with Indigenous people and lands. By voicing our respect and responsibility, we can strengthen our relationship to the land that sustains us with the Indigenous people who hold the lands sacred and to one another. And specifically, I want to point out some further readings on this. And this is a very good book that I have been fortunate enough to read by Elwood Jimmy and Vanessa Andriotti. And this is about Towards Braiding, where we can decolonize and reconstruct a meaningful relationship and with respect for each other and the land itself. Specifically, I would like you to move further and actually acknowledge the main participants and the organizers of the CrossTalk, and specifically, we all hail from different parts of Canada, from University of Guelph, from McMaster University, from Queen's University, and University of British Columbia. And I don't want to go specifically and acknowledge each one of us, but I would like to generally say that we all recognize and acknowledge and find it necessary that we need to acknowledge the land and its significance and the Indigenous population that have kept it sacred and kept it for us so that we can flourish in the same. Thank you. With that, I would like to quickly summarize today's CrossTalk session. We're going to have about 50 minutes or so of some esteemed thoughts being discussed by panelists that have been invited specifically for the topic today. And following this 50 minutes of a dialogue with the panelists, we shall move forward to breakout rooms so that we can have a chance to talk to these panelists on our own personal time and reach out to them and connect with them on a very personal level and explore ideas and knowledge transfer in these breakout rooms. We would also be following that with the trivia. So we want to keep your attention. So we're going to have a gaming period at the end of the breakout session. So please wait for that. And it's going to be a lot of fun, and going to test some of your materials and metallurgical knowledge. And it's aimed to have a very good fun session of trivia. And with that, I want to introduce the moderators, who are also the emerging professionals of MetSoc today, and they have aligned themselves with the Light Metals Committee at present. And it's Abdullah El Said, who's on the kayak, who's an assistant professor in the University of Guelph, and Jessica Hiscocks is from Queen's and Kingston Processing Metallurgy, and she is also another very enthusiastic emerging professional and who loves to hike and the outdoors. And finally, and not least, it is Michael Benoit, who is an assistant professor in the University of British Columbia in the Okanagan campus, and he is joined in and is joining in and taking the reins of the CrossTalk from this session onwards. And I welcome all the three members of a very motivated team to take this to different new heights. And I really hope that you enjoy the session today of CrossTalk. Thank you. With that, I will give the podium to the moderators.
Thank you so much, Sumant. So Abdallah Al-Sayed here. Thank you for the introduction as well. So today's session, well, our overarching goal for CrossTalk when it was started was to kind of create frank discussions with professionals on light metals and light metals development. And then so the moderators, we looked at trying to do a survey to see what topics of interest would be for students as well as professionals. Our first crosstalk a few months ago was well attended, and we were talking about light metal casting, particularly aluminum casting. And so we had industry experts from industry as well as in the mining sector, looking at the life cycle of aluminum castings and their development and what was kind of upcoming in those areas. So today's crosstalk was another hot topic that we thought would be of interest to a lot of people, would be the intersection of computer science and materials development. So how could we use computer tools or all digital tools in order to accelerate and promote and advance light metals development?
So the overarching crosstalk goal is to provide a place where we can create frank, informal discussions between industry personnel and those interested in working in light metals or becoming industry personnel. It is intended to be an exchange of viewpoints and knowledge and encourage collaborations and connections. I just want to notify everyone that we will be recording the panel session, which will be on the internet afterwards. Our next event is in 3 months or so, is going to be to do with the recycling of light metals. And for now, I'm going to pass us over to Michael, who will introduce our panelists.
Hi, everyone. First of all, thanks to everyone for joining. We really appreciate you being here and showing your interest in this crosstalk event. As Sumant said, my name is Michael Benoit. I'm an assistant professor in manufacturing engineering at the University of British Columbia on the Okanagan campus. And I'm also one of this year's emerging professionals in the Light Metal Committee. And I think before we get into the panelists, I think two other people that we need to acknowledge for their involvement in sort of organizing everything that happened today were two of our sort of administrative people at the Canadian Metallurgical Society, so Brigitte Farah and Victoria Wu, who are also joining us today. So I'd like to extend a sincere thank you to them for all the hard work they put in sort of making this event happen as well. Okay, so moving on to the topic of our panel discussion today. As Abdallah and Jessica mentioned, it's looking at digital tools and how they can be used in both process optimization and materials development. And I think one of the exciting things about our panelists that we have today is that they represent a number of different points on the value chain in terms of actually developing this sort of software, selling the software, and actually using it to create products and processes. So with that being said, we'll start by introducing our first panelist, which is Matt Reid, who is a software engineer at Liburdi Automation Inc. in Dundas, Ontario. So Matt Reid is as I just said, is the software engineering manager for Liburdi Automation Welding Systems. And he spent 15 years designing and developing software to automate the specialized welding processes provided to customers in nuclear, aerospace, and medical industries. And he's currently leading a team that provides advanced and innovative tools to allow for the development of welding processes that repeatedly deposit high quality welds to a wide variety of new and in-service components. So Matt has an honors Bachelor of Science degree in computer engineering from the University of Waterloo. Our next speaker is Nicolas Poulain, who's the Director of Sales and Technology at Transvalor Americas, which is a manufacturing process simulation software. So Nicolas has more than 15 years of experience in the field of finite element method or finite element analysis simulations. And he's expanded his expertise in multiple industries, including automotive, aerospace, and the energy sector. With the background in material science, Nicolas has worked his way up from the pre-sales engineer to now being the Director of Sales and Technology at Transvalor Americas. And he's passionate about helping clients get what they need to serve their business best and to succeed no matter what their marketplace is. So thank you, Nicolas.
Hi, everyone.
And then our last speaker today is Christopher Kohar, who's a senior crash structures engineer at Rivian. Dr. Chris Kohar is the Senior Crash Structures Engineer at Rivian Automotive. He spent over 10 years, or he has over 10 years of experience developing advanced CAE simulations and tools for the automotive and manufacturing sectors. He completed his PhD in mechanical and mechatronics engineering. That was at the University of Waterloo, and Chris was my colleague during that time. We did our PhDs together. But during that time, Chris focused on multi-scale modeling and optimization techniques using AI for enhancing energy absorption characteristics for lightweight automotive structures. Dr. Kohar was awarded the Early Career Researcher Award from the Scientific Committee at this past International Conference of Aluminum Alloys. And that was for his contributions to computational materials engineering and design with aluminum products. In his current role, Chris is responsible for and he leads the development of various structures used in electrical adventure vehicles and delivery vans at Rivian with an emphasis on lightweighting and safety. So thank you to Chris. And now that we have introduced all of our panelists, I thought we would start off our crosstalk today with a few basic poll questions just to get the audience, a bit of interaction with the audience. But the other purpose here is that we want to sort of get a sense of where everyone is joining us from, both geographically as well as their background. So our first question is going to be a question about where are you joining us from in the world? So you please just take a moment and answer the poll question on the screen here, and it'll give us and our speakers a good idea of where people are joining from and what their backgrounds are. A few more seconds here, got about 10 more people to participate. Okay, so it's looking like most people are from central or east coast of Canada, a few from the US and a few joining from other countries. And it looks like I'm the only person joining from the West Coast today, which is okay. Maybe out of interest, those people joining from other countries, maybe just type in the chat, where are you joining from? Where in the world are you? So we'll move on to the second question. And our second question is more about your sort of academic or professional background and training. So if you want to share the second poll question. Okay, so the second poll question should be on the screen now, and it's essentially, what is your background or training? Or what is your current role? Are you in university, college, graduate student? Please take a moment to respond to that. So if you could, you should see a poll. I'm not sure if everyone can see the poll. It should be on the slide.
I think it's going now.
Oh, no, there we go. Yeah, great. Thanks. Okay, so it looks like most people are joining us either as a graduate student or from industry. So for those of you who took part in those polls, thanks for that. And I think it gives a good sense of where our audience is from, so our speakers can sort of direct their questions accordingly. So thanks again for participating in the polls. And with that, I'm going to turn it over to Abdallah, who will start off our questions for our panelists.
Thank you, Michael. We'll have other poll questions throughout. So I get the fun part of starting off with the first question to our panelists. Okay, so what is your day-to-day work day like? What are you currently working on? And would you say you're more of a kind of developer or more of a user? Maybe I'll start with Matt to get the ball rolling.
Thanks, Abdullah. Our day-to-day can change quite a bit depending on what we're working on. A lot of our customers, our division specifically, we make 3 to 12 axes welding machines, and we're more of obviously a process company versus a machine building company. But so they'll come to us with a certain repair that they need to do for their production requirements. So most of our customers are aerospace customers, and they have a certain part they need to repair. And as you know, all the engines are constantly changing. And so we've been able to repair a lot of the components, but obviously there's new ones that come up each time. So they'll come to us, and then we'll have to try to develop the repair. And then once we develop the repair, then we'll recommend a machine in particular to do that repair. So that usually depends for us to come up with some new software to access or to meet their requirements for their production goals as well. So I'd say we are developers and users. So the user side of it is our weld lab that has to come up with the repair. And so our group works closely with them every day to determine what features, what new ideas can we come up with to be able to complete this repair up to the metallurgical standards that they need. And so once we figure that out, our team will obviously develop the software or add features to our machine or to our control software to be able to do that. And then depending on day to day, if we're in the start of the process or testing the process, we'll work closely with them to ensure that's working properly and to the standard that we needed to. So.
Great. Maybe Nicolas, if you wanted to chime in too, in your kind of day-to-day work life.
Sure. Hello, everyone again. So, we're Transvalor Americas, we develop software. So obviously we're more from the development side of things, even though as personally in my group more users who kind of consume the simulation. So day to day, obviously our goal is to reach out to prospect people who do not have simulation software yet, or also obviously with the technical support, help out our current users. But I would say it's mostly awareness. Make sure that everybody is aware there are solutions for them to help them. So that's what we do. And day to day, mostly we have a lot of pre-sales activities. So it's gathering all the data we need to plug into the software, run simulation, and usually do a meeting like that, a video conference, and build a report. Giving some recommendations. Say, hey, that's what we see. You may have a potential issue here, etc. So those things. Okay,
yeah. So it seems like for both of you, it's still, you might be a little bit more on one side or the other, but still have to really work really closely to, if you're a developer, really closely with user. If you're a user, really close with your developer too. Yeah.
Well, absolutely. It's a loop. Basically, it's it fits back to the DevOps, and then come back and we use it. So we, in some sort of kind of like our customers in one way. We do use the simulation software to run simulations, but we have also the opportunity to talk to our DevOps, which we can implement something.
Is it similar for you as well, Chris? Same way, kind of this continuous back and forth.
Yeah. So from our end at Rivian, we're actually, I would say, more generally the end user for some of these softwares. A lot of the work that we do in our team is for safety and making sure that the products that we're developing are safe for the user at the end of the day. And so we use a lot of finite element tools and finite element software optimization tools to be able to do our product development. In terms of also additional software, we will do some internal in-house development based off of what we need in terms of software.
Sounds good. So you guys talked a bit about the product development process. Maybe if we can dig into that a bit more detail, how you develop the process or how you use the software to facilitate product development, and especially how do you identify a need? How do you identify a client's need? Nicolas, can you start us off on that one?
Yeah, so again, I'm going to start from the software perspective. So software development, and Matt and Chris can talk probably more about the industry, even though I can give some little feedback based on what we see with our customers. So for us, the development of software is triggered by two main avenues. One is long-term, which starts into usually university projects. So you have either one company wants to start a project, or then multiple companies who wants to work toward a common goal. And so basically you have universities involved, PhD students working on that. So that's a long term, because usually to get to the final goal, you need to run several phases, several PhD students working on a small part of each of the entire project. So that we follow that, we always involved in the development of that, but it's more like a standby until we consider there's something substantial for the industry to use. Now, the other avenue is mostly customer requests that we are going to implement. And when I say customer request, it can be just a features, which that one is really a short term, it doesn't take long usually. But you can have also midterm projects where we know by feedback from customers there's a need for this industry to develop such model or whatever it is, and then we start putting together how do we get there, and then it's all the development process. So those are the real two main avenues to develop a software. For customers, it's more like usually how it does is they have a request from their end customers, and like, hey, I'd like to, if I talk about forging, for example, I like to forge this part, and they are going to log into it. Usually they use simulation to test ideas, make sure they have the right equipment to forge that or cast the part. And then go back and forth, and then they follow quotation. But I think Matt and Chris are probably better to talk about that.
Yeah, it's very much the same in our group, but as I would say, the two main inputs would be our research and design lab that are basically, they're in charge of developing a repair process for the end customer, and then once they've developed the process and they've come to us to say if these tools would be nice, so we help them develop that. Then once the customer is happy with that, the customer needs to put this into production. So then they want to know how can we keep the quality of this repair process, and how can we ensure the integrity of it through 10, 20, 10 million parts, right? So then we start developing more quality tools. Right now, there's a big push for quality tools. So how do we inline make sure that the laser or the welding arc is doing what it's supposed to be doing? And so we're developing new tools, new sensors to constantly watch this, constantly keep track of this. And if something goes out of the key range, then we'll flag it, and then we'll let the customer know that this part may have an issue, and then they can check that. So it's continuous quality over every single part.
So it sounds like a lot of the development is kind of driven by customer requests and things that customers tell you that they want. Is there a significant fraction you'd say that is more sort of driven on your end, things that you see a niche for?
Go ahead, Matt.
Well, obviously, we've been adding metal for, I want to say, 20 years to different components. Now in the last 5 years, 10 years, additive manufacturing. So yeah, we're definitely trying to, we see what an additive manufacturing machine can do. And so we're also looking, our machines can already do this. Let's also convert them to how the industry sees these other machines do it. Because and from our side, we've always looked at the metal to make sure that it's high quality, excellent results, where everybody else, well, a lot of different, I want to say additive companies just make a nice part at the end of the day, but have they looked at the internal structure of it? They are obviously more and more, but we've always started with that and went the other way. So, but in the same sense, we also see the enormous market for that as well.
Yeah, and just wanted to rebound that for us is, I mean, obviously the opportunity comes from what we see. So, I mean, it's usually, the market or the industry is asking. But for example, talking about welding, Matt will probably validate that with me, but we recently developed a new simulation software for welding, for many different type of welding. And that's funny because we had a lot of interest by many companies in that. And it's not something we developed because people came to us like, hey, we need that, but we kind of created a market on that. I mean, mind you, there are some simulation software on the market too for welding, but what we saw is we have a lot of different advantages with the experience we have in microstructure, casting. Basically welding is kind of a association of all of that, and we could provide information to the end users that all the software could not. And what we realize is like I said, the software market could not provide all this information, and people like Matt basically developing their own tool to address those issues. And when you're not a software developer, the development company, you have certain budget, financial restrictions that you cannot go all in, and things that we obviously we have budget restrictions, but we have also the knowledge, experience from all the solutions we already have in the market. So that's how also we kind of see and predict where we should go in terms of market.
Thank you for that, the really good discussion of that. Now, just to make sure that our attendees are still awake, we're going to ask them a little bit about their backgrounds. So we have another live poll question for everybody in the audience to tell them about your backgrounds. I think we've got a large number of materials engineering people here. Oh, and we've heard from 75% of our participants. All right, I'm just going to end the poll and share the results.
Yeah, it looks like a little split between the materials and mechanical.
Lots of materials and mechanical people.
So, which I think brings us to the next question for your colleagues, Nicolas, Matt, and Chris. What are their backgrounds? The people you work with, as well as maybe people that you hire.
Sure. I'll kick this off. So again, my background is I'm Canadian, born and raised. Because of COVID, we all have very interesting work locations. So I'm technically based out of Irvine, California, and Plymouth, Michigan. However, I'm hired out of our Rivian office out of Vancouver, BC, and currently located in Ontario. I do spend a lot of time traveling all throughout. My background is actually within mechatronics engineering before I started to do my PhD, which was, as Michael had introduced, which was at Waterloo. In terms of the company that I participate at, which is Rivian, we're relatively new, but a large corporation. We have around 10,000 people that we work with. Just like many other automotive manufacturers, we do have a fairly large product development team with members from all over the globe. We do have a very heavy presence in the United States, just because our nucleuses of our headquarters are there. We also do have a fairly large team from China, from India, and from Europe, particularly from the United Kingdom, because we have a development office out there. Our teams, in terms of who we interact with, again, they're quite cross-functional in terms of various specializations, mainly from materials manufacturing and both mechanical design. I would say generally for the colleagues that I work with, especially in product development, many of them are mechanical materials and system engineers. We generally all have masters or a PhD at least. We do also have a couple of members that do have a bachelor's degree, generally very fresh out of undergrad. We actually do have an interesting program that we have those new students that bring on. We do actually have them go through different placements throughout our company to be able to get kind of some exposure to what they're looking for. And generally, in terms of myself, I would say, again, from software perspective in digital tools, I would say I'm generally an end user, as I mentioned. I primarily use a lot of finite element and optimization tools to be able to develop lightweight structures. As again mentioned, we do use a lot of commercial software, but again, we also do some of our development internally based off of some of the niche items that we think will give us a competitive advantage and help us to be able to, again, make some of our products the best that they can be. Generally right now in the automotive industry for some of these tools, there's a lot of attention now being generated to try to automate the process. Longer the days are of engineers and scientists manually processing and looking at data, because computers have really evolved now. We can just plow through and generate quite a bit of data. And so now what's happened is we've created all this data. We need to kind of find ways to be able to leverage that information in terms of to be able to exploit our products as best they can be. In terms of those type of applications and special projects, generally, again, we would have quite a few members that have completed some type of graduate degree, usually a PhD in either mechanical engineering that has a good programming background. And especially also for doing some of the manufacturing optimization, again, understanding how the material behaves in a mechanical perspective and how, again, we can either manufacture it or what the performance is going to be.
Great, thank you for that insight. Matt or Nicolas, if you want to chime in as well.
Well, I can give you, it's first for me. So here in Transvalor Americas, we're mostly users, as I said. So profiles usually materials engineer or mechanical engineer. So that's what we hire with, basically we want someone who fully really understand material behavior to help our customers, and also hands-on on anything IT basically. All right. And but back in France, a parent company for development is usually PhD students who went through material science associated to finite element method basically. So there's few universities where we can recruit this profile.
Yeah, Liburdi, it was Joe Liburdi. He's a materials engineer, so our company was founded from a materials standpoint. But since then, we've developed into a pretty cross-functional team. But it's always been a focus on materials at the end. But from the team now, we'll work right from the guys repairing the components, which could be Boilermakers, to weld technicians. So there's good weld tech programs in Canada, and then it'll move up the product development chain. So we'll have a group of engineers. My group actually now is a lot of mechatronics engineers. So we focus on software, but they've looked at the software from an automation standpoint. Most of the software guys go to software companies now, and the mechatronics automation, we tend to get a lot of guys that are interested in mechatronics, got mechatronics backgrounds, but we also build power supplies, so we're electrical, and then the designers are mechanical engineers. And so then it moves all the way through that, so.
Great, thanks for the perspective from all three of you.
All right, now I think we're going to ask another audience poll question. Specifically, have you ever considered a career in the software industry? I noticed that a lot of the people listed their background. Well, actually, nobody listed their background as being in computers, but as we've heard from our panelists, there are lots of opportunities for people with a materials background or mechanical background to move into the computer industry. All right, so we have, looks like we have a number of people who thought about it and decided it wasn't for them, and a few people who are in it or are thinking about it. So that's good to hear. And
Okay, so we'll move back to another question for our panelists, and this one kind of stems as a bit related to their previous question about where new employees kind of come from. Our next question is, what advice would you give to a student who's thinking about entering into this industry, either on the personal side or the professional side, or just any general advice? And maybe we'll start this off with Chris.
I'll have to think about this one. I would say right away, for students and young professionals that are entering, and especially in this industry, at least in my industry, especially with doing a lot of structural design and leveraging materials, we really need to, I think, have students read and think more critically about the software tools that we're using as an end user. Again, we use a lot of nonlinear finite element analysis to be able to do some of our structural design, whether or not it's a battery pack from when we're modeling thermal mechanics, understanding the materials that are going into building a battery cell itself and how that's going to perform, or even structural applications where we have to start to choose what the particular material is, how do we process it, how are we going to join it. Again, a lot, we also do we have to understand then when we do these simulations, what's the expected performance, right? And so what I've noticed over the years is at least a lot of the tools that we're developing for these softwares, I mean, they're fantastic now, and the accessibility to them is paramount. Many CAD softwares nowadays come with standard finite element and CAE and design optimization packages, and it's no longer needed that you have to go to school to be able to have to learn it, right? Because all the information is, a lot of it's on free tutorials on YouTube and other platforms that can kind of teach you how to run these tools in about an hour or less. But essentially, that's all they're intended really to do, these tutorials, is just teach you how to run a tool. But the theory, the understanding of how these tools work still requires quite a bit of many hours to be able to learn. Although these tools, again, are starting to kind of replace some of the expertise from the software trainers and university courses, it still doesn't teach you the fact that you need to spend physical time and hours to truly understand the tool. And this is only accomplished by really reading and thinking critically. These are be able to ask questions like, what is it that I'm actually simulating in my simulations? What is it that what are my materials that I'm actually putting into it? What are my assumptions about all these models? And what do the results look like when these assumptions are violated? Again, these softwares are great because they're remarkably easy to use, and we can produce results regardless if you violate these assumptions. But the key thing is these softwares will never tell you if these results are producing something that makes sense or reasonable. If the software could actually tell you that the results are meaningless, well, then engineers and scientists would be out of a job. Because that's the one thing a computer can't do, is to tell us, are these results sensible? A lot of the times I would say we're really obsessed with generating some of the plots. For those that have seen CAE analysis, the graphs are really pretty, but sometimes we don't take the time to be able to zoom out and ask ourselves, again, do these results make sense? And one of the key things is, again, if you don't even know what questions to ask, you can't have that opportunity to be able to do that. So it's my opinion that the only way to be able to understand on what questions to ask, to be able to use these tools effectively, is to be able to read up on them, pick up the theory and spend the time to be able to really dive deep and understand what this tool is meant to do, how we can actually use it, and then figure out what questions to ask.
Yeah, great. Thanks a lot, Chris. Appreciate that. Maybe we'll move to Nicolas. Do you have any advice for students or recent graduates or people who are maybe looking for a job in the sort of software or simulation industry?
Yeah, and before I'd like to add to Chris, I think that's really important what you just said, and that's true. And even more so when you talk about optimization. So software have automatic optimization added to it. And, one of the first thing you want to do when you start an optimization is, what is it you want to optimize? And most of the time, people don't know. Like, I don't know, I just want to optimize my process. Well, it's like, okay, but we need something a little bit more precise to, what do you want to optimize? Is that the strain you want to reduce, and things like that. So that is really important to be critical thinking. Sorry about the phone ringing in the back. For me, what I would recommend is more about personal skills, and I think the three key skills to have is first, don't be afraid of change. So try to be a least resistance of change. There's a lot of things going on in any industry, and if you fear change, you won't embark early enough in this, and you may be able to play catch up afterwards, but you're gonna miss the first wave. So you want to be aware of what is happening, how it may help your company or what you're doing. So that's the first thing. Second is in that vein too, is flexibility. For many things, you can be able to, maybe you have something in mind that you're sure this is gonna work, but then you have to be able to change your mind based on discussions with your colleagues, and say, well, you're right, maybe that's not the right solution. So you have to be able to, again, critical thinking. And the last thing is team player. You have to be able to work with a team. It's really, really important. I would say even more so today with all that's going on with COVID and all of that, where now you're no longer pulled into a meeting room. You have to, put yourself into those, Zoom meeting or equivalent, Zoom conference. So you have to be invested and really willing to play as a team player, so that everybody moves into toward the same goal. So I think that's more interpersonal skills that I will recommend to have.
Yeah, thank you, Nicolas. Very thoughtful and thorough response. And Matt, did you have anything to add to any advice to new graduates?
Yeah, I'd say from a software standpoint, I agree a lot with Chris and what Nicolas have said, especially what Chris said. In terms of, from a software standpoint, we learn how to build software, and that's our expertise. But a lot of times in this industry, we're not building software for a touch phone app. We're building it for either simulation or industrial machine. And at the end of the day, the outputs from that machine or that simulation, you need to be able to work with the experts in that field to understand what the software should produce. And if you don't, if I have guys sitting at their desk thinking they know what it should produce, then end of the day, it's the wrong item. So they have to work with the cross-functional team to determine what is the end goal and how do we get there. And not from a software standpoint, we can make those decisions internally, but from the outputs of the software at the end of the day, that needs to come from the experts in that field. So ideally, you need to work with the team and know and close the loop early from a software standpoint to make sure that what you're going to produce is going to be what somebody needs.
Yeah, perfect. Thanks, Matt. I appreciate that. With that, I'll turn it over to Abdallah to ask our next question.
Yeah, so we have another poll that should be coming up on your screen. Yeah, so it's more related to what kind of software you've used, not so much the brand itself, but the kind of what is it looking at, or what is the software focusing on? We just give a little bit more, another moment for everyone or a few more people to put in their responses.
So Abdallah, do you routinely use any of these?
I think more of the thermodynamic modeling. Yeah, one or two different companies, but more on the thermodynamic model. We have done some FEM more on they work on more metal casting for aluminum and magnesium. And so some fine element more on to kind of, sometimes we're making a little mold. And so we just want to make sure it's filling properly. I'm not a pure modeler in that sense. I'm kind of like the fluid dynamics, but more on the thermodynamics. What phases am I expecting, and when will they form? These kinds of things.
Makes
But
sense.
yeah, almost even split between both. So I think we touched upon the next question I have for our panelists. We touched upon it just in the previous one, but I think maybe more focusing on the interpersonal skills. Maybe what do you think the young professionals are lacking, and has this maybe changed in the last few years or so?
Yeah, in my opinion, at least from what I've observed in my experiences, I think some young professionals, and even some, I would say, not even just limiting this to young, but both those that are both in leadership and management, lacking some level of empathy in terms of what it means to be successful in industry. It's really important to kind of recognize that everybody has different aspirations. Some people are perfectly happy dedicating their entire life to work, doing 60, 80 hours a week, no vacation. They wear as a badge of honor on their chest. Others are perfectly fine working 30 to 40 hours a week. They have other things that they like to do to be able to go travel. More importantly, spending time with their kids. What we define as success is not the same as others, and that's perfectly okay. As managers and leaders and team members, we really do need to be able to accept this fact. I know that in some of my past experiences as well with industry, like again, sometimes when you see a colleague taking vacation frequently, it's really common to kind of hear the whispering down the corridors of them, but because they're taking so much time. But sometimes, again, people don't really understand what people are going through in life. Life's quite crazy and whatnot. So I think being able to kind of, again, zoom out and put yourself into other people's shoes and being a little bit more empathetic for what they're doing. And we have to find ways to be able to accommodate that aspect of it. So that way we can, again, have a fairly good balance in terms of individuals and what they want to achieve.
Yeah, Nicolas or Matt, maybe Matt, any kind of interpersonal skills you think young professionals are lacking, or people right out of school, or maybe just a few years in, and then if things have changed in the past little while?
The only one I can see, which I sometimes push my guys to do, is actually pick up a phone and make a phone call.
Oh.
Everybody's happy to text, email, and wait for that email, but a lot of time, if you call somebody and talk to them for 10 minutes, you can solve a lot of problems really quick. But I think it's just the way of the world. But at the same sense, it is sometimes, and a lot of people don't want to do that. But at the same sense, 15 years ago, that's all you had really, and you could solve stuff, and sometimes it's fine, and it depends. And sometimes we're building something and we need to get something solved quickly, and there's a rush to do it, and I'm like, and that's one thing. But most of all, they figure it out.
I totally agree with Matt's comment. I don't know how many times a text or an email, the tone has completely been lost. Yeah. And it's simply sorted out by either picking up the phone or even just going and sitting down and talking to them in person. Yeah,
I can definitely rely with that too. My colleague told him that probably just call him and you'll figure out much easier than by email, where you have 10 exchanges and still cannot figure out exactly what is wrong. Where you pick up the phone and you're like, oh, okay, so that's your problem. So yeah. Communication skills is probably what is lacking the most now.
Thank you for the insight.
So we've got another question for our attendees. Have you ever created or programmed software? This is kind of the gateway into working in the software industry. seeing some sort of software thing for personal hobby. A lot of courses now incorporate some kind of programming work. Sometimes people do this for household stuff. There's all kinds of household Arduino-based projects and so on. And certainly lots of online support and magazines dedicated to programming your own projects. So it looks like the majority are no, some of who want to, and some of who oops. Oh, okay. Some of who want to, and a number of whom have no interest in giving it a shot. Okay. So we've got one final poll question, followed by which we'll have one last question for our panelists. So the last question for our attendees is, has this talk changed your level of interest in the software industry? Have we increased your interest? Have we persuaded you that it's completely not for you? Or have we done absolutely nothing to affect your opinion of the matter?
We're anxious on that one. It's basically giving a note to a panelist, right?
We'll find out after this poll result if we are invited back.
Yeah, I think we were kicked out of the door. We're welcome to come back.
Yeah, I think our poll isn't up.
Software.
Add your answer. Oh, add your answer to the chat. Okay, so type it in. Type in if we affected your opinion. But for our panelists, no matter what, our next topic is completely different. So it's 3 different people every time. So no matter what.
So we're kicked out no matter what. Is that what you're saying?
But it's been great to have you here. It's been great to hear lots of interesting things about the software industry. And as always, the ever-present computational reminder that garbage in equals garbage out, and that computers make very fast, very accurate mistakes. Our final question, people can type in their answers to the poll question as we go. We'll just continue on talking to panelists. So this is more of a societal question. What hurdles does your company see in terms of diversity equity? I'm going to ask Nicolas to start us off.
So personally for my company, basically none, to be honest. There's no hurdles. And I'm quite optimistic for many reasons. But the way first, the way we interact now, we don't have to go to a specific location. I mean, again, I'm talking about my industry, but more and more even in where you have operations, some managements and others can be located anywhere. So you can access this pool of people that you cannot reach before. So I think it's more like opportunities than hurdles, to be honest. I think there's more and more acceptance by a lot of people, and that's funny because it seems to be opposite to what you kind of read on social media or even just regular media. For what I've seen and when I've been to many forging companies, steel wall companies, heavy duty companies, there's more and more acceptance of either women into the workforce, and any type of whatever your religion, your skin color, or anything. I think there's more and more acceptance. I mean, we're not there yet, but I think we are, we are able to reach out to way more people that we used to. So I'm an optimistic. So I think there's more opportunities than hurdles.
So let's vote in favor of COVID and remote working for terms of accessibility.
it definitely accelerated. This move was kind of happening, but there's some resistance. And now when people are put into, well, you have no choice, you have to do it. Well, it kind of broke these barriers, I would say. I mean, not everywhere, but still work to be done. But yeah, I think it helped. There's one thing that COVID actually helped with. So here we go.
Yeah, well, it kind of proved that it could be done.
Right, exactly.
Matt, you have anything to add?
No, I agree with Nicolas. It's more of an opportunity. Like our workforce is it's worldwide. We work with customers all over the world, and so it's always been kind of built into our company culture. But at the same sense, I would say personally, the only hurdle I've seen in a bit, and it's gotten a lot better, is I want to say the application pool, like the skill set, right? So from a software standpoint, 15 years ago, I want to say it was very male dominated, but in the last 5 to 7 years, I've seen, I usually go back, I'll hire co-ops from McMaster and Waterloo, but in the last 5 years, I'd say the ratio has gotten much, I want to say much more even, right? In terms of who's coming into the interviews, who's applying for the job, who has the right skill set. So I think it's been a big push throughout the last 10 years, and I think we're starting to see the results of that.
Okay. All right. Well, that's some good perspective and some good input. So we're actually just going to take a 5-minute break shortly. We're all going to move into the breakout room, but because it's a small group, we're all just going to stay in together. So I would like to take a moment to thank all our 3 panelists for their time and expertise and valuable commentary. Those of you that can stay, we'll see you in the breakout rooms. If not, thank you for joining, and I hope to see you for our next crosstalk, which will be on the topic of light metals recycling. This is the end of the recorded portion.